All right, it's time to take a look at some of these trouble questions from the practice set 41 through 50. Looking at your guys' comments below, I definitely noticed that 43 and 50 were the two, 43 and 49, I believe, were the two challenging questions. So we're going to start with number 43. Both of these questions have to do with trigonometry. Trig is something that you should be getting right now as a junior. Um, if not, if this stuff doesn't look familiar by the time our ACT approaches, I can definitely do some mini lessons with you. I think I can still explain this to you fairly well, even though you have zero background on trig for the most part. When we look at the coordinate plane, we know that this axis, we could refer to this as a 0-degree angle. So if I was to draw an angle right here, and it was actually on top of itself, it would be 0 degrees. As we go up here, straight up would be 90 degrees. As you know, this would be 180 degrees to make a straight line. And downward would be 270 degrees. We can continue going in increments of 90 to create this circle to look at some of these angles. Angles can also be measured in radians. And a lot of times with trig functions, we use radians. So this would be 0 radians. The equivalent to 90 degrees in radians would be pi over 2. The equivalent to 180 in radians would be pi. This would be 1.5 pi or 3 pi over 2. And then one full revolution, the same as 360 degrees, to be 2 pi. So in this problem, it says we're talking about an angle that's between pi and 3 pi over 2, which basically is a way of just telling us that we're in this quadrant right here. Now, what I'm going to do is I'm going to draw a triangle. So I've got to create an angle someplace in this quadrant, and I'm going to make this right here, theta, my angle. It tells us that the sine of theta is -3 over 5. Well, we remember that sine is opposite over hypotenuse. So what that tells us is it tells us that we have to go back 3. So based on this angle, not back, but based on this angle, the opposite is 3, and the hypotenuse is 5. So opposite 3, hypotenuse 5, and those values come from this right there. Now, the negatives will fall into place. We can see that if we're looking at the coordinate plane, this would be -3 because we're down 3. And we can also use special right triangles to show that this is -4. So we have a 3, 4, 5 triangle based on theta in quadrant 3. This is our drawing. So now, based on this, it wants to know what is the tangent of theta. Tangent, you remember, is opposite over adjacent. And in this particular case, opposite would be -3 over adjacent to theta would be -4. So this is the opposite. This is the adjacent. And -3 over -4 is 3/4. So J is the correct answer. If that makes any sense to you, that's pretty impressive, not having a huge background in trig. This is probably the easiest way to do this. There's lots of other ways, but hopefully understanding triangles and just our basic trig, opposite, adjacent, opposite hypotenuse, adjacent hypotenuse, sine, cosine, tangent functions will help you out. The other question I want to take a look at here is number 49. 49 also is directly related to trigonometry, something you're probably going to learn this year as juniors with Mr. Gibson. But we can still take a look at this. This one is actually probably easier done than 43 without having any background of trig. What it's asking us to find is we're trying to find the sine of pi over 12. So pi over 12, again, is an angle in radians. It has some measures here in this chart of sine, cosine for different radian measures in this column. Now, we'll notice that pi over 12 is not one of the measures in this column, but it's telling us that pi over 12 is the same as pi over 3 minus pi over 4. So pi over 12 can be replaced with pi over 3 minus pi over 4, and then it gives us this big long equation. Well, what we're going to do is we're going to relate pi over 3 to alpha and pi over 4 to beta. So we have the sine of alpha is pi over 3 minus beta pi over 4. And we're just going to plug that into this equation. So it says that we could take the sine of alpha, and remember again, based on this equation, this is alpha, this is beta. So based on this equation, we could take the sine of alpha, which is pi over 3, times the cosine of beta, which is pi over 4, minus, jump down to the next line here, cosine of alpha, which is pi over 3, times the sine of beta, and that's pi over 4. Now, all of these values right here, if I was to look at this value and this value and this value and this value, they can all be found right here in the chart. So we're just going to replace that. Going back to our original equation, this is then going to be equal to sine of pi over 3. Pi over 3, sine is right there, root 3 over 2, times cosine of pi over 4. Cosine pi over 4, right there, root 2 over 2, minus cosine pi over 3. Cosine pi over 3 is 1/2, times, finally, sine of pi over 4. The sine of pi over 4 is root 2 over 2. Now, all we have to do is simplify this, and when we simplify this expression right here, we multiply across the top, we get the square root of 6 over 2, minus the square root of 2 over 2. We're subtracting, so when you subtract, you end up with the square root of 6 minus the square root of 2 over 2. Common denominator is 2. We have common denominators here, so we don't have to worry about common denominators. We combine the tops, and we get square root of 6 minus square root of 2 over 2. So this is basically just giving you one of these theorems. This is actually a difference theorem that you'll have to memorize as juniors in trigonometry. You'll memorize that theorem, and then you're just taking these values out of this theorem from the table there, and there. Okay, it does help that they told us that pi over 12 up here is equal to pi over 3 and pi over 4. So we knew based on this expression right here that this is going to be alpha in the equation, and this is going to be beta.